Get ready for an interstellar shock. Due to the fact that a group of Betelgeuse's mesmerizing scientists, Ryan's bright red supergiant, yes, your shoulder has already burst. Yes, you are correct. We are not joking. Within the next 10 so years, its brilliant aftermath will last for decades, illuminating the night sky. But how did we arrive at this conclusion? Should we allow scientists to make this claim? Be concerned that the James Webb Space Telescope could capture the remains of Betelgeuse today. We're going deep into Betelgeuse with all the most recent information. One of the prominent stars in the sky above us in the northern hemisphere during winter is Betelgeuse, a red supergiant star, isn't it? It's one of the few stars that shine brightly enough for us to actually see its reddish-orange color with the naked eye. Betelgeuse is typically the 10th brightest star in the night sky, but as you may already know, it's always been known to have varying brightness. A portion of Betelgeuse is the reason for this. It's not at all your typical star, because of its massive size. If we were somehow able to use our own Betelgeuse in place of our little sun, it would stretch out all the way to the asteroid belt and have a mass of an astounding 20 times that of the sun. It may surprise you, but actually Betelgeuse is quite young for a star, whose age is thought to be between 8 and 10 million years. By comparison, our own sun is much older, with a 4.6 billion year age estimate. This is because supergiant stars like this kind of massive star burn quickly through their nuclear fuel and go supernova relatively quickly on geological timescales, which also means they change quickly. Betelgeuse might actually have done that right before the eyes of humanity. To comprehend how researchers arrived at the conclusion that Betelgeuse had already burst into flames, it's important to investigate the context. The story begins in the 2nd century BC, when Chinese astronomers made a noteworthy observation that Betelgeuse exhibited a distinct yellow hue. Fast forward to the middle of the 2nd century, and the Greek astronomer Ptolemy referred to it as orange-ish or ruddy, the same as it appears today. Similarly, medieval people who watched from the Middle East witnessed a similar coloration. This raises the question of how colors were named or perceived in the past, but in this case, there is an actual likelihood that Betelgeuse changed color within a few centuries. Chinese astronomers may have observed Betelgeuse during its yellow supergiant phase. For a number of centuries, it transformed into the red supergiant phase. Given that humans, by our nature, are night sky observers, you have to wonder how many people all over the world were aware of the star's change, but did not record it. After every star change like that probably came with all sorts of dimming and brightening events that aren't recorded. Imagine them pointing up at the night sky and saying, "Hey, didn't that star once look brighter?" This is exactly what's been happening right now. Betelgeuse is a fluctuating star, but it seems to conform to some cyclic conduct. Beginning in December 2019, Betelgeuse's brightness abnormally dipped by a huge amount, which was distinctly apparent to the naked eye for those who were used to looking at the star. It was not its usual self until the beginning of 2020. It improved over time. And one theory was that some of these cycles had coincided, making for a particularly deep dip in brightness. However, observations by the Hubble Space Telescope pointed to something rather odd. Betelgeuse appeared to have expelled a great deal of material, hurling it into space to form a huge cloud of dust. This cloud of dust, in turn, blocked a significant part of the star's light when viewed from our perspective. The transformation was quite astonishing. Betelgeuse, once counted as one of the 10 brightest stars in the night sky, faded to a point where it was ranked below the 20th brightest. It was truly perplexing to witness its dimness in comparison to its neighboring star, Aldebaran, which currently holds the position in terms of brightness. Thankfully, Betelgeuse showed signs of improvement, but its peculiar behavior did not stop. In fact, it is right now displaying a state even stranger than merely dimming. In recent months, Betelgeuse has undergone a significant increase in brightness that is greater than its normal brightness by a staggering 50%. This puzzling situation is quite unsettling for a star that is known for its dimming events, which may be caused by dust, coinciding cycles, or perhaps the star developed huge sunspots. However, a significant increase in brightness is something else entirely. Although it could be related to the preceding occasion when Betelgeuse expelled material in the event of 2019, it likely caused a substantial disruption in the flow of the star's plasma. The current behavior we observe could be considered a sequel to that ejection. But what lies behind this peculiar behavior, surpassing the star's typical variation? A conservative hypothesis that has been extensively debated is that Betelgeuse is nearing the supernova phase. While conservative estimates still suggest that the star is about 100,000 years from a supernova event, there is evidence to challenge this notion and demonstrate that it may have already taken place. So what is the evidence? According to groundbreaking research from the past few years by Hideyuki and colleagues at Tohoku University in Japan, link in the description, Betelgeuse already went through a supernova explosion, and we may be witnessing the aftermath of this cosmic spectacle within the next 10 or so decades. That's correct. As amazing as it sounds, the last observed supernova in our galaxy was Kepler's supernova, which occurred way back in the 1600s. Through a thorough examination of Betelgeuse's variability patterns, the researchers' findings include, for distinct shifts that occur on a regular basis, at intervals of approximately 2,000, 200, 420, 230, in 85 days, while the origin of the longest period remains unknown, is speculated to be the fundamental period, with the shorter intervals potentially serving as overtones. The researchers propose a model that suggests Betelgeuse is in a late stage of carbon burning, implying that it may be on the verge of a dazzling explosion that positions it as a prominent candidate for the next anticipated supernova occurrence. Within our galaxy, the Milky Way, in terms of shedding light on the mystery surrounding Betelgeuse, there's a bit of a puzzle. You see, there are some conflicting observations regarding the ejection of materials and the star's subsequent recovery. The general consensus leans toward an event of mass ejection, something not entirely unheard of for various types of stars, although on a smaller scale compared to our own sun. But here's the twist. Supernovae are real. Additionally, we actually observed one in a satellite galaxy of the Milky Way in 1987. So, while it's possible that our estimates for Betelgeuse's explosion timing could be off, don't plan a vacation around it just yet. But the tricky part is that Betelgeuse is currently tricky to observe. It has slipped behind the sun and will no longer be visible until at least August. As a result, we are left unaware of what this mysterious star is up to at the moment. What we do know, however, is that it's bucking its typical trends by increasing right now. Betelgeuse's immense size and relatively close proximity, 650 light-years away, await us to actually resolve a disk. The majority of stars, when observed, are simply too far away, appearing as mere points of light. But Betelgeuse provides us with a rare chance to catch direct variations in its light, output through photography. So we not only have a star that is likely to explode, but also a lot of data to collect, including pictures, even though they may be a bit blurry. Let's imagine Betelgeuse's situation. If it has indeed gone supernova, what would it look like? First, it's going to be a real spectacle. But don't worry, it's perfectly safe for us here on Earth, you see. Betelgeuse is actually quite far away, so it won't cause any harm to our planet. When it does go supernova, though, it won't be the brightest object in the sky. The moon will still outshine it by far, and let's not forget about the sun, however. It would definitely cast its own shadows during the day and remain visible at night for approximately a year. Here's the interesting part. The supernova would be visible at night for several years, gradually fading away. There might be a brief period where it regains some of its brightness before fading completely. Its earlier splendor, but eventually it will keep going away until the familiar shoulder star within the Orion constellation completely vanishes. While this won't put us in any danger from the supernova, it could certainly cause some confusion. Some animals rely on moonlight for navigation, and with an additional bright light in the sky casting shadows, it might cause them to falter a little. But astronomy isn't just that. It would face some challenges observing the night sky from Earth. During times when the bright moonlight could be a little tricky, a very bright supernova would only complicate matters further. However, there would most likely be more telescopes interested in capturing the supernova's glory above all else, even if it means altering their observations. In addition, before the visible explosion, there would be some warning signs, such as detecting gravitational waves and neutrinos from the star. But here's the big question. If Betelgeuse has already gone supernova, could we possibly seize the remaining items? We must await the James Webb Space Telescope to detect the supernova remnant. So how long could it take for Betelgeuse to go supernova? We're not certain, but it could occur as soon as next week, next year, or in 100,000 years. In cosmic terms, that's basically the same as currently. It's easy to forget that the light from this star we can actually see is centuries old, and if it blew up 600 years ago, we wouldn't even know about it. What do you think? Could Betelgeuse have already gone supernova, or is it just exhibiting unusual variability? Let us know in the comments. Naturally, the James Webb Space Telescope is the ideal instrument for making these observations. We don't have to wait long before it solves the mystery once and for all, the quest to understand. Betelgeuse's behavior and its implications for stellar evolution involves a comprehensive strategy combining observational astronomy, theoretical modeling, and historical context. This star, well known for its variability and massive size, provides a unique opportunity for astronomers to study the life cycle of supergiant stars and the phenomena leading up to supernova. Firstly, it's essential to grasp the significance of a supernova in the broader context of cosmic evolution. A supernova is more than just a stunning event. It's a critical process in the life cycle of stars. These explosions play a vital role in dispersing heavy elements all over the galaxy, like elements forged in the cores of massive stars, into interstellar space, contributing to the formation of new stars and planetary systems. Thus, the study of Betelgeuse and similar stars helps astronomers comprehend the galaxy's chemical enrichment and the mechanisms driving stellar evolution. The upcoming or recent supernova of Betelgeuse would mark a pivotal moment. Researchers in the stellar life cycle are particularly interested in the governing mechanisms for the transition from a massive star's final stages to its explosion. Current models suggest that, as supergiant stars like Betelgeuse approach the end of their lives, they go through a series of intricate processes, including core collapse and the ejection of outer layers. These stages are characterized by significant brightness and observable variation. Scientists can study Betelgeuse to learn more about these processes and refine their models of stellar evolution. Moreover, the historical records of Betelgeuse's brightness variations and its documented color variations provide valuable clues about its past states. However, observations made by ancient astronomers, restricted by their time's technology, have provided a baseline for comparing current data. The transformation from a yellow to an orange-reddish hue over time may reflect the star's internal changes and its progression toward a supernova. This historical perspective improves our comprehension of how massive stars evolve and how their life cycles impact the potential of the environments around them. Turning Betelgeuse into a supernova also intersects with our understanding of cosmic events on a larger scale. For instance, studying supernova contributes to astronomers' investigations into the circumstances resulting in a variety of explosions, such as Type I and Type II supernova. Type I supernova are typically the result of thermonuclear explosions in binary star systems, while Type II supernova, like those expected from Betelgeuse, arise from the core collapse of massive stars. Understanding the differences between these events can help scientists piece together the history of our galaxy, as well as the regularity of such occurrences. Observational difficulties, like Betelgeuse's current position behind the Sun, highlight the complexities involved in studying dynamic celestial objects like these. Despite these challenges, astronomers use various techniques to monitor stars that are, for instance, temporarily obscured. They employ space-based observatories and advanced telescopes to track the star's light curves and analyze its spectral data. These methods provide crucial information about the star's composition, temperature, and potential for a supernova. In addition to these techniques, the use of theoretical models plays a significant role in predicting and understanding supernova events. Scientists develop simulations that incorporate current observations, historical data, and physics theory to predict how a star like Betelgeuse might behave. These models help in predicting the timing and characteristics of the supernova, providing perspectives on what observers might expect and how the explosion will impact the surrounding space. The implications of a supernova from Betelgeuse go beyond astronomy. For instance, a supernova of this magnitude contributes to our understanding of cosmic radiation and its effects on Earth. Although Betelgeuse's distance ensures that it poses no threat to our planet, the study of supernova contributes to our familiarity with cosmic rays and their interaction with Earth's atmosphere. This data is essential for understanding space weather, its possible effects on satellite systems for operations and communication. Finally, the potential discovery of Betelgeuse's supernova remains a source of excitement and intrigue within the scientific community. The event would not only advance our knowledge of stellar life cycles but also captivate the imagination of the public. The dramatic visual impact of such an explosion, visible for months or even years, would inspire a new generation of astronomers and space enthusiasts. Public interest in astronomical events often fuels educational outreach and promotes scientific literacy, emphasizing the importance of continued investment in space research and exploration. In conclusion, the potential supernova of Betelgeuse represents a significant milestone in our understanding of cosmic events and stellar evolution. Ongoing investigations and theoretical work surrounding this star contribute to a deeper understanding of how the universe works. While we wait for more data from the James Webb Space Telescope and other observatories, the study of Betelgeuse continues to provide valuable insights into the dynamic processes governing massive stars and their ultimate fate. Whether Betelgeuse has already exploded or is close to this dramatic event, its narrative emphasizes the ever-evolving nature of our research into the universe and the never-ending search to uncover its mysteries.